right, well, here's a few news articles. Ethereum has moved high. Ethereum is the number 2 digital currency, and apparently for the first time ever, Bitcoin is less than 50% of the total cryptocurrency space, and I think what they mean here is market capitalization. This is logical. Bitcoin was the original cryptocurrency, and it doesn't have as many features as Ethereum. There are hundreds of them, but those are the big ones. The one you hear more about these days is Dogecoin, and we'll see what comes of that. Definitely in my cryptography class next semester, we'll talk a lot more about these and the technical comparison of them, so you can understand the various features they have. But the main feature is that Bitcoin is just for money, and Ethereum lets you run programs on the blockchain, although they run hideously inefficiently. But that's a feature of all proof-of-work blockchains, is that everything you do takes about 1 million times as much CPU as traditional ways of doing it, which is why it's extremely difficult to justify using a blockchain for anything. But anyway, people are doing it, and we will set them up and study them. This Havana attack came out a couple years ago. American diplomats in Havana started getting headaches and strange symptoms, and it turned out it sounded like some kind of paranoid conspiracy theory, but a lot of them had real brain anomalies, and apparently they were under attack by some kind of weapon, like a microwave or a sonic weapon, and now it's happened twice in the United States near the White House. So nobody knows what this is exactly, but it is supposed to be some kind of experimental weapon somebody is testing, and if they're testing it in Washington, then we really need to find out what's going on there. I guess it might possibly be some new disease or something. Anyway, they're investigating it. I first saw reports of this a couple of years ago, and I thought it was maybe just a fantasy, but it seems more and more real. This is the way it tends to go. When AIDS came out, the U.S. government tried to deny it completely, and same thing with Legionnaire's disease and chronic fatigue and fibromyalgia. There's a lot of diseases that come out, and now for a while, long COVID. There's a lot of diseases that come out, and when they first come out, there's just a few people, and they try to say, oh, you're just making it up or something, and it takes a while before they start taking it seriously and trying to really track down the cause. I didn't know this. I know Apple's App Store charges 30% of all the money you make through in-store purchases and buying apps. And apparently Microsoft Store has been doing the same thing, which is kind of hilarious considering how few people use the Microsoft Store. But now they're cutting it to 12%, and this is because they're competing with Steam, which is the competing product on the Microsoft ecosystem. So we'll see. I think there's probably going to be federal antitrust regulation cutting that fee of 30% on Apple. But we will see. But I mean, Elizabeth Warren and the people who want to do antitrust are targeting that as a case of abuse. I see my window should move down a bit. All right. Get this about the right size. There. Anyway, so the U.S. Labor Secretary said gig workers should be classified as employees and have some benefits, and this is, of course, what Uber and Lyft and DoorDash have been struggling very hard to prevent. Their whole business model relies on this gig model, which is a very old model, before we had any social safety net where you would just be making things like shoes and you just get paid by the piece. So their stock all fell sharply when the suggestion came out that they would be required to offer benefits to their employees. So we'll see what comes of that. There's a large gig economy in America, and there's a lot of pressure from the Democrats to offer benefits to those gig workers because a lot of people, instead of having a real job with benefits, they have 2 or 3 gig jobs, so they end up still living in poverty even though they're working hard. So here's a nice analysis at Investor Place. I liked it a lot, explaining what's wrong with Dogecoin. As you know, I'm very, very opposing all cryptocurrencies as investments. And here he explains it with Dogecoin because I used to work in pyramid schemes, financial restitution for pyramid schemes, and that's all they are. If you have an investment that is not based on any actual product of any value, then it's just floating on air and it will just fall. And that's what this guy talked about. Dogecoin And he just talks about how the problem is people are throwing real money into Dogecoin, which was originally just a joke. And the point is it's selling at some price. It went up to like 10 cents or 15 cents or something. And it wildly jerks up and down because there's no real reason for it to have any value. And now people put in billions of dollars. And what happens is after a while, people get less confident and they start selling. And once a few people start selling, everybody else tries to sell quickly because the price is dropping, and then it drops down to zero. That's a run on the bank, and that's what caused the Great Depression and many other financial catastrophes. So, if you're putting a few dollars into something for a joke, that's one thing. But if you're putting billions of dollars into something that doesn't make any sense, then sooner or later it's going to collapse, and then you're going to be sorry you put so much money into it. Here's what he's saying here. Sounds sensible to me, although it's out of fashion in the modern economy. Biden is, the Republicans have said Biden was going to take away Dr. Seuss. Wow, Doge went up to 43 cents. Wow, I didn't know it got that high. Yeah, they're talking about Doge making it to $1, which would be a huge advance. Anyway, the Republicans said that the Biden administration was going to ban Dr. Seuss, and they were going to ban Mr. Potato Head, and they were going to ban meat. And none of that was true, but apparently they really are going to ban menthol cigarettes, which I've heard of this. Menthol cigarettes are apparently marketed specifically to target black smokers, and they're extremely effective. Like 90% of black smokers smoke menthol cigarettes, so the Biden administration believes that if they can ban menthol cigarettes, it will greatly decrease the number of black people that are smoking and getting sick with all the diseases. So that's a new one. First I've heard of that. So this is relevant to you poor students. These are all the security certifications, and just mind-boggling. I saw a talk from a blue teamer with all the commercial products you might buy to protect your network, and it was like this, 100 brand names. So this is the very idea that there even exist this many is crazy. How could anybody even understand these many topics or even enumerate them or anything? It's kind of nuts. There are a few that are really well respected, like Security Plus for beginners and CISSP, but there's just many, many, many more. Obviously, you could go nuts with this stuff. And as a college, we do the same thing everybody does. We try to find like the top few of these to put in our classes. But if you're in the world of security, you should know, you should get Security Plus and CISSP. And then OSCP would be good if you're a real hardcore pen tester. And there's other ones that might be helpful after that. But Security Plus and CISSP are the really big ones that everybody will like you to have. The rest of these are all kind of specialized for one field or another. But anyway, might help you to see some attempt to organize it all. The world of security has gotten really big and really complicated. So this one I thought was very nice. Tucker Carlson has been pushing this, which is a standard white supremacy model, which is that the Democrats are trying to let more immigrants in the country because then they will vote, and they think they'll vote Democratic, so they will replace the white people with these non-white immigrants, and they will then take over the government and ruin your life and take away all the stuff that you treasure as part of white culture. This is a very common white supremacy talking point, and now it's mainstream republicanism. That Fox News has gone completely full white supremacist, and the Republican Party has been taken over by open, obvious Nazis. Now, I'm not lying. They meet on the Nazi symbol, and they moved into that. And this is an interesting point, which I hadn't heard before. If the problem is, this is the same problem every nation has had since ancient Rome. The rich, established ethnicity stop having so many children. Rich people usually don't choose to have large families. So the white people are not having very many children. So if you don't let immigrants in, we're going to have the same problem Japan has, I think for the same reason, that you have a bunch of old people trying to get supported with Social Security by a small pool of young people who you're trying to tax more and more to pay for the old people. So they're pointing out if you actually want the white people to have a comfortable old age and retirement, then you need to let in a lot more immigrants so there's more young working people to do the work and pay the taxes. That is an interesting argument. But if you do succeed in building the wall like Trump did and shutting down all the immigrants, then you will create a shrinking population of old people, which is not the way to maintain a healthy economy. Anyway, as anybody could have predicted, healthcare workers are very, very, very burned out and disgusted they are sort of like people. I mean, I guess I'm older than most of you, but I lived through the Vietnam War, and it was really a gruesome thing. People would go serve in the military, try to help their country, and when they come home, they'd just be spat on instead of being seen as heroes. And the health workers feel this way. I mean, they have to go risk their life. They work under awful conditions, seeing a lot of people die, being helpless, and then they come out and everybody's just ignoring the COVID precautions and saying it's not real, and they feel, unappreciated and abused. And a bunch of them, like 30% of them, are just going to leave the profession. This is quite understandable, and it's interesting to see the evidence of it. All right. Anyway, we're up to the official time. So this is 129S, Securing Web Applications. And as you know, the semester is coming to an end. We're down to the last chapter, or near, the last chapter. So this is attacking users, other techniques. And one more lecture here. I haven't decided what to do for the last class. I will announce it later. And by the way, there's a lot of guest lectures coming up, which are all worth extra credit and very much worth going to. You'll see them down here. A bunch, 3 more on Mondays and Tuesdays. Real security professionals. So I highly encourage you to tune into these and learn more about security jobs that are available and the training required and what people do and that sort of thing. So here we are. Attacking other users. So we're going to talk about request forgery, a big important technique. And so this is where you somehow take over somebody else's session and execute activities that they did not want to execute. That's request forgery. You somehow create a request that appears to originate from someone else, even if it doesn't. And so, for example, let me bring up this example here. I'll see if I have Firefox. Here, Firefox. There we go. And somehow it's not appearing. Okay, there. So, all right, and the one I want is CSRF demo. All right. So here, let me blow this up. You have a message board. You have a question, you have a name, and you have a message. When you submit it, you see a picture symbolizing your question, then the name of the user, and then the message. When you examine the source code, let's get rid of that and view the whole source. Okay. Then you will see, here's the message I put in, and here's the message, here's the name. Here, this part of it, question, that came from me. That was under my control. This part of the form back here was question. So part of what I put in actually ended up inside an image tag. And that means I could inject script in there. So here's the attack. What you do, you could post this on a message board and people would see it. And so here's the attack. You put this stuff in the type field. And now, when you submit that, this is just showing that it's going to work. And you can see why it worked if you view the page source. The reason it works is because this now does this. It goes up to some other location. I think it should be a .. anyway. And then it calls a PHP file with this stuff and then closes it. So the point is, when someone views this page, it performs this PHP script. It makes a request. And so if an administrator person views this page, which you can expect when you're submitting a question to the trouble ticket board, an administrator person will view the ticket, and viewing this page will cause their browser to make a request up to this script, newusers.php, and that will execute that code. So that's on-site request forgery. I put something on your site, and when another user views that site, it does something with their privileges that they didn't want to do. So that's a simple case of on-site request forgery. All right. And so if you have a stored cross-site scripting vulnerability, this is what the Sammy worm we talked about was. He put a page-containing script on MySpace, And when other users of my space viewed it, it executed the code in their browser with their credentials. So it didn't have anything about mixing two sites. It was not cross-site. It was one site where my code injection runs on that site. All right. So that's the kind of thing that's, all right. So and there are other examples. For example, if you're doing this and you can't put in less than and greater than sign because they're being HTML encoded, you can still inject code like we did there. You just put this stuff in the type parameter, and therefore just viewing the image will take effect. And this is like the request handlers we talked about last time. There are ways to inject code that will have an effect even without injecting less than and greater than signs. All right, so if you want to prevent this, you've got to validate user input. In this example, you would not let someone put in arbitrary strings for type. You just restrict it to a few values like question, comment, something like that. If you filter out special characters, it can help, but it's not a very strong defense. And so the one you always hear about all the time is cross-site request forgery, the version of this that involves two sites. So you create a website which will cause the user's browser to send a request to a vulnerable application. And the thing you're exploiting here is that even if you're on one website like Microsoft, your browser can make a request to Amazon, and if it does, it will include the Amazon cookie. So I could have a link on Microsoft that when you click it went to Amazon. That's legal. And your browser will just blithely include the authentication cookie. So that's the thing. If I could somehow make a web page that automatically clicks that link and it goes somewhere else, then you would take an action with your privileges on the other site without having agreed to that. That's the game here. The point here is the same origin policy. Now, the same origin policy means if I am Amazon, my server can only see your Amazon cookie. And even if you send a request from that page to some other website, like Yahoo, I cannot see the result at Amazon. The data won't reach me, but the request still takes effect. So that's the same origin policy. All right. So for example, there's some page where you can make a new account with this new user, step 2, which has information down here about the new user you're creating with a password and a role, administrator, and a username. So there is some kind of script, an ASHX script on the server. All right, so if the request performs a privileged action and the only authentication is the cookie, and if I can control all the parameters, then I can cause my website to make your browser make that request. And so here's what you do. You have a form action like this, and then you have all this data, filling them in with default values, and then I have a script that automatically hits the submit button. So you don't even need to press the submit button. As soon as you load the page, the JavaScript in your browser will press the button for you, so you won't know it has happened. So this will execute that attack over to this other site. All right. So this happened to eBay. In eBay, when you put an image on the products you're putting on eBay, you could include script that would automatically make people bid on it without their consent. So that was a real-world example of this happening. All right. So the fundamental problem here is, of course, that your cookie is all you need to authenticate, and your browser automatically sends the cookie with every request. All right. Another example is DSL routers. Most users don't change anything, although with modern devices, they often won't let you have just a fixed default password. But anyway, so your web page can automatically make a login request, and then you'll have a cookie to get a session token, and then I can perform an action like turning off the firewall. And my web page can do that, even though I'm not on the domain, your local domain that goes there. I cannot see any of the answers due to the same origin policy, but they will take effect. And this is something you see when you're hacking websites. I mentioned before, when you start sending injected code up to vulnerable websites, often you don't get an answer that lets you see it's worked. What you often get is a 500 error. Something's wrong with the script because the output of that injected command doesn't meet the formatting expected on the server. So at first I thought that meant my script was failing, but I learned that usually means your script is succeeding. You managed to break the response so it's no longer valid. So you often have to do this blind hacking where you're executing things and you cannot see the results, like blind SQL injection. All right, so if you want to present this, then you have to have authentication that doesn't rely on just a cookie. You have to have something else, like a hidden field. This is an anti-CSRF token that means you must really have come from the page where you are expected to make this request. It can't be that I had some other page, like an evil page, that made this request. You had to really come from my domain, my page, where you are really trying to do this. That's a way to make sure that you didn't come in an unexpected direction. And that's one way to do it. As long as the token is not predictable or guessable, then my CSRF attack won't work. Now here's another attack which I'm only going to go over briefly because I think browsers no longer allow this, at least a lot of them. Now if you have a page and you visited links, they'll appear in a different color, and this is still true. But this was recognized about 10 years ago as a possible vulnerability because I could query your browser to see. I could load a page, and then I could query your browser to find out what color it appeared on your browser. So I could find out if you had been to this site. So one simple thing you could do is you could make a list of like the top 100 sites, and then when you go to my page, it will query it without you seeing it, make invisible links to those pages and see which ones have changed color, and then I could pop a box saying, you have been detected going to this site, you now have to pay the FBI, because I can tell what sites you've been to recently by what color they render on your page. And that eventually got people mad enough that I think they've implemented some defenses against this in at least some of the browsers. But that's the game here. So now, if that were to happen, if the anti-CSRF token was short enough to be guessable, like 3 digits, I could make a page that had hundreds of these links with different possible CSRF tokens, and then I could interrogate your page to see which one turned yellow, and now I could figure out which token you had by doing this. That's what goes on here. This is a brute force attack that my server could make on your browser without causing it to make any requests externally at all. I'd just be asking your browser, what color is the one with 1, 2, 3, 4, 5, until I find the one that has the other different color. All right. Anyway, so an anti-CSRF token would present this where I'm on, say, forum.com, but now I'm going to load an image with a file name that goes to Amazon by. So in this case, the browser will send an Amazon cookie. And if I'm only authenticated by the cookie, it'll work. But if I also need some form, some hidden form field that would only load if I was really went on the Amazon buy page, I won't have it, and so this will fail. Unless I can somehow find or guess the anti-CSRF number, which could be added to the URL here. So, all right. So that's the game. That's what you need to have in modern pages is an anti-CSRF token. And I've got Cahoots, theoretically. Looks like Kahoot is doing weird things to me. There we go. All right. 13A1. Good. I hope we got more coming. We kind of need 4 or the competition loses its meaning. That's close. Okay, good. Now we're up to 4. I'll wait a few more seconds and see if anybody else wants to come, but 4 is enough. Oh, okay, good. Even more coming. Okay. All right, guess that's it. All right, so what will prevent CSRF? Yep, yeah, the hidden field is the anti-CSRF token. All right, which attack requires a stored cross-site scripting vulnerability? All right, that's it. The on-site request forgery requires something like MySpace, where I can save something on the server, which will then run script when other people view it. All right, which method of authentication causes CSRF vulnerabilities? Okay, that's it. The problem is the cookie, and the browser automatically attaches the cookie to every request. All right, so what kind of attack was the Sammy worm? All right, that was on-site request forgery. That was the MySpace attack. All right. All right. That's not necessary. Okay, so, all right, so now we'll talk about UI redress. M, okay, good. I'll make a note of that. All right. So this is where you confuse the user by making the page look differently than it really is, so that clicking on one element affects a different element. They also call it clickjacking. And the trick is you open something in an iframe and make it invisible. So you're clicking to win, but there's another invisible page here where you're doing something else. And let's see, I had an example of this. Let's see if I can find it. UI redress. It should be UI, because I read it in your book, of course, and then I wanted to try it out. So I set it up. Okay, so here, here's the good button. You win an iPad. Here's the bad button. You get hosed. All right, and now here, I put opacity at 0.1. And now there's win an iPad, and there's this faded thing, and when you click it, you get hosed. And here's the impossible choice. There's opacity of 0. So this is the iPad, but on top of it is that other frame, hosed, and it's completely invisible. So as you can see, they're not kidding. This is pretty bad. You click on something, and there's really no clue at all that you're really clicking on something else. So this got people all excited a few years ago when it became clickjacking became a popular topic at security conferences and demonstrations of it. You could, in principle, do some really nasty things this way. You could also capture keystrokes and move them to another page. There's one where you would have to like type a sentence into something like a typing test, and it was picking certain characters out of that. So you're executing a command to change your password or something. There's a lot of these. You can steal mouse movements where you have to play a game where you're dragging something and you're actually dragging something else, having a different effect. Even selecting text. So frame busting is an attempt to defend against this. The idea was you put a script on your page that detects if it's actually loaded in an iframe, which is a little page within a page, and if it is, then it busts out of the iframe and goes to the top so that nothing else can be on top of it. That's the idea. This was an attempt to defend against it, but it turned out to be a really bad idea. And in 2010, they found that all the frame busting defenses were all circumventable, because if you're trying to use script, so here's an example. This is script that will tell you if your page is not loaded at the top, move it to the top above everything else. That sounds pretty good, but the problem is JavaScript, being a weakly typed language, lets you overwrite things. So even though top location in the document object model is supposed to refer to the location of the top of the page, you can redefine it so it is something else, and then so you can change the result of it that way, and you can hook the event for for unload here to redirect it to something, so the browser will just give up trying to find the top and not run the script. You can define something called sandbox, and that disables scripting. If you load in a sandbox frame, then no scripts inside the frame are allowed to run. So if I do that, then it's going to stop your anti UI redress script. And this one I thought was even more entertaining. As we've talked about, I use Firefox for my demonstrations because most browsers now include anti-cross-site scripting defenses, where certain code that looks suspicious will no longer run in the browser. The browsers have sort of a built-in antivirus-like thing. So what you can do is you can deliberately add malicious JavaScript to your page so that the anti-cross-site scripting filter will block all the script in the iframe thinking it's malicious. So you can use the security feature to kill the other security feature. So that was kind of cute. So anyway, those turned out to be miserable defenses, and the better defense, which has certainly caught on, is to have these security headers. So you have a header in the response from your server which specifies right at the top rules about whether this page is allowed to load in a frame or not. And so if you set it to deny, then it cannot be loaded in a frame at all. And if you set it to same origin, then it can only be loaded in a frame if it's on a page on your own site. And that's much better. That's much more likely to work. Of course, nothing's ever perfect. For example, if a user is using a really old browser version, then it won't know what to do with this header. But I don't know how much most browsers automatically update these days, so I would imagine most of the time you don't have to worry about that too much. Another issue is mobile devices. Mobile browsers are different, and a lot of people thought that they didn't have this problem, but the problem is the mobile page can be used on a desktop machine too, and often it is, and often the server-side image is the same for both the mobile and the desktop page. All right, and so you're not supposed to have code from one domain from running on another domain, but there are ways to do it. You can load files from another domain and add them to your page. So I can, for example, if I can do some injecting up here, and down here I have an email page where it's going to send some email someplace here with this action, forward email, but I can inject code before it. Then I can inject code that will erase or alter the function of the code coming after it. For example, I can load a partial image tag that does not have the ending quote or the ending bracket, and therefore that will eat up some of the code that the developer put there and turn the page into something different. And in this case, it will actually capture the token and send it up to my server. And here's another injection. I can add another form tag. So now there are going to be 2 form tags on the page, and what will happen is the first form tag here will define the form, the second form tag will be ignored, and now when you execute this form, it'll send it to my server instead of your server. So, all right. And another cute one is injecting CSS. You can inject, even if you can't inject less than and greater than signs, you can inject curly braces and inject cross-site scripting. Now, if you do that, it will put the entire response into a cross-site scripting thing called font family. Now, the font family is supposed to be a name like Arial or Courier, but now all this data has been turned into the font family. And that will include all the secrets like this nonce, which is the anti-CSRF token on the page. So to fetch it, I'll have to host a page and include that CSS page here. So I load it as cross-site scripting on another page and then read it that way. So it's a way to trick your browser into passing it over. And there are several fundamental weaknesses of the web that are exploited here. One is that one file contains several languages mixed together. And another is that browsers accept broken pages. They don't just stop like a C compiler and say this page has a syntax error and quit. They try to repair it and use it anyway. And so those things working together mean you can do these attacks that involve reinterpreting text written in HTML as if it was CSS. And the browser will go along with that. All right, you can also load JavaScript from another domain and use it. That's expected. In fact, it's common in these days with these advanced JavaScript-based frameworks. So, for example, if you log in and click Show My Profile, then it runs a Show User Info script. And that page dynamically loads this script here. So the script gets user data and runs this Show User Info function. The problem is it loaded it from a separate file, and I could make a page that loads from that file. So I make a page that loads the same script remotely and then runs a Show User Info function, but it has a different Show User Info function. This is also exploiting the fact that JavaScript is object-oriented, and you can redefine functions at the local level. It will override the higher level script. So again, this is a trick. So if someone views the malicious page, it will load this and then do something unexpected with the answer, like send it to me. All right, so if you want to prevent this, you can use anti-CSRF tokens to prevent these cross-domain requests. You can, this is a kind of a cute one, I've never seen this, but you could poison your JavaScript so it will never run if loaded normally. Like you have an infinite loop at the top, and then when you really load it, you'll have to use XML HTTP request, which can load just part of a page, and you can load the part that doesn't include the poison, and that is only permitted from the same domain. So that sounds like a pretty kludgy, nasty solution, but it's an option. All right. You can also only allow it to be loaded via post requests and so on, so they can't do it with cross-site scripting. And in HTML5, you can modify it, and then you can have permissions. So the browser adds an origin to the request, which tells you what site made this request, and then you can specify what origins are allowed to load this. This sounds like a much better defense to me. Like I say, these headers are much better. Now your response can just have these rules where I'm only going to let you see this script if your origin is my approved origin. This seems a whole lot better than that crazy thing where you actually add an infinite loop to your script. That seems like a really dangerous way to solve a problem to me. So anyway, we got another Kahoot, which would be here. And we are done with 13A1. And now we're up to 13A2. Good. Got more than 3. Might have one more if it's like the last one. Apparently not. All right. All right, so what's the weak defense against clickjacking? Framebusting is a script that tries to detect if your page has been loaded in an iframe, and there are a bunch of ways to stop that script from working. All right, what's the way to steal a token with HTML injection? All right, adding a second form tag can redirect the contents of a form. All right, how should you stop clickjacking? Yeah, X-frame options is the header that will stop pages from loading in a frame, and that will stop it at its source. All right, what header field in the browser that adds, yeah, it can be added to XML HTTP requests. It is always added to them. The origin tag tells you where the request came from. All right, and which one is clickjacking? That's UI redress, another word for the same thing. All right.